Hi, folks, and welcome to Spring at IETF 106. If we can get started, if possible, please, because we have, as usual, a fairly packed agenda, and as of yet, I don't remember us having ever run to time on the agenda. This is the note well, given that we're Monday morning, then maybe you haven't seen it already. If you haven't seen it already, please read through it. If not, if you have, please be aware of it. Please note it well. We have Shuping is going to help us with the minutes, and I think PK said he would as well. If we could do with a Jabber scribe, though, if anybody would like to volunteer for that. Oh, can you hear me better now? Oh, turns out I'm being quiet. I know it might be a shock that I'm being quiet. Okay, the minutes can be collaborative. The Etherpad is linked here because it's got an IPv4 literal in the URL that it links to now, rather than etherpad.itf.org. So you can find it either linked from the slides that we uploaded or in the minutes. Did we have any volunteers for a Jabber scribe? No. Anybody who's willing to relay questions from Jabber, please. So we're going to be blocked on continuing the meeting by having somebody to do this, please, because it's kind of important to allow remote participants to be able to collaborate with us here. And this is one of the ways that people ask questions. So it would be, I can do have anybody who has a Jabber client that's willing to relay questions, please. Okay, Martin's made some noises, so we'll assume that that's able to be, and I'll try and jump on as well. One small update, but it's been exceptionally useful for helping Bur and I pull together this meeting. We now have a secretary. Thank you very much, Shuping, for your efforts here. She has immensely helped us pull the materials and the agenda together for this meeting. So thank you very much indeed. Yeah. So some updates about the working group in general. There is this large cluster of documents, CU340, that's in the RFC editors queue. We are, the majority of them are now in Auth48, and they include some of the pretty key documents that we've had for a while, including those that sort of initiated Spring. So some of the work like the MPLS draft, and then the IGP extensions that support the base SR functionality. They're now all in the RFC editors queue. I think there's essentially a lot of these are linked together and blocked on the same documents. So once Auth48 is done on all of these, then I think there's only the EP that might be the EP and ones which are both IDR drafts, and maybe the BGPLS one that'll have other reference dependencies. But once this is done, then we'll be done with the the kind of key SR and PLS documents being standardized, which is an awesome milestone for the working group, and something that I know folks have been involved in for the last 3 or 4 years. So I think hopefully next time when we're in Vancouver, we'll be able to have all these RFC numbers baked in, and to take a little time to congratulate the working group on having standardized SR and PLS finally. We have a number of active working group drafts, some of which we've adopted since the last meeting. The 2 service programming and NSH documents have been adopted since then. We then have the past segment work, the work on SR policy, and the work on the Yang model that continue to be kind of progressed and living working group documents, and then the SRv6 network programming draft, which we have an update on today. We have a couple of adoption calls that we're hoping to kick off after the meeting. One of them on the replication segment, Dan's draft there, and then G's draft on the enhanced VPN capability. As usual, as we go through adoption call, it'd be really great to get some technical reviews on these documents so that we've got we've vetted them as they come into the working group and become working group documents. As is the case, has been the case for the last few meetings, Spring continues to coordinate with a bunch of different working groups, and since the last meeting, we've discussed with a couple of other working groups where some documents live. The performance measurement and the in situ OEM documents will be handled in MPLS because these are both documents that really relate to only the MPLS data plane, and we didn't necessarily feel that they needed to be hosted in Spring. For the TWAMP draft, then this is work that we discussed with IPPM, and they would prefer that we host it in Spring. So Spring will as this document progresses and is presented and updated, then we'll continue to have it in the Spring working group. So coming on to the large amount of discussion that we've had on the mailing list since the last meeting. First off, thank you for the active discussion. It's good to see that the mailing list continues to be useful. I think for a few meetings before this, we've had fairly quiet time on the mailing list. So it's good to see that we had some active discussion there. Bruno and I and Bruno discussed with Martin. We wanted to sort of take some takeaways from that discussion. I think we continue to have some consensus around SRv6. Both operators and vendors are interested in the way that using SRv6 in its current form, and there was kind of no strong indicators that this isn't something that we should progress. So what we'd like to do is to continue to progress this work, especially as it's been work that's been progressing in this working group for a number of years. There was, though, some interest to look at reducing the header size for use cases that need many SIDs, and both operators and vendors within the working group showed some interest there. Our observations are there's several solutions for that on the table. I mean, the SRv6 work, the microSID work that we heard about in the last meeting, are both examples of that. But what we kind of felt was that ahead of time of like choosing between those different documents and looking at the way that we want to progress this kind of specific use case, then we need to be explicit about what the goals and the costs of each of those proposals are. So what we were inviting authors to do is to be explicit on both of these things within their documents. So we can, whilst these documents continue to evolve, as individual drafts, we're kind of clear what the benefits and the costs of each of them. And our real push here is to try and complete the SRv6 work that we have, that we've engaged with Sixman on, that the working group's been working on, and use the learnings there to try and guide some of these future decisions as to what the next steps after that to maybe address some of these larger SID stacks should be. Kiriti.
Hi, Kiriti Kampala. Is it the best approach for the IETF to complete SRv6 before really digging into these other proposals? Or is it better for us to actually look at all of them and see if maybe there's something there that either we come back to SRv6 and do it slightly differently, or maybe even say that's not completely the best approach?
But I think if we block any solution on having the best solution, then the IETF would never iterate on anything, right? So I think the problem is that there are folks that are I mean, it was pretty clear across the comments on the mailing list that there are folks that are using this technology. So it's not unusable if we publish it. Yeah. So it kind of feels like it's a reasonable thing to say, hey, let's make sure that the bits that we are standardizing, and that I think we should be open to saying there's parts of the SRv6 solution that we don't need to standardize right now because they're not key, and sure. Then we have a stake in the ground for solution 1, and then we start looking at solution 2. Otherwise, we might block solution 2 on solution 3, and it's henceforth forever.
I wasn't saying block anything. I was saying more like get a little further down the path of what's right and what's wrong about the current approach and what are the things we want to fix. And if we then say the current approach is fine, then go ahead with that. But the idea that we complete this and use the learning from this to inform the rest is fine. But I think we could actually go a little further down the path of doing the analysis.
Yeah, I think absolutely we should continue to examine these other bits of work. I think what we're just saying is that Spring, what we'd like to do as the chairs and the AD of Spring is to allow that to happen, not necessarily in the framework of them being working group drafts.
Okay. All right. Thanks.
Darren Dukes from Cisco. Just to reiterate that, what you said, there are a lot of deployments. I mean, this stuff is deployed, it's working, it's functional, it's implemented multiple vendors. The standardization of it by this working group is seems to be obvious at this point for SRv6.
Hi, Andrew. Rob, my concern with this approach on that last bullet point is that you end up creating a potential situation where some work is potentially hostage to other work, because it effectively says that if you want to advance other work, you have to agree to advance this first and effectively rubber stamp it. Because by not doing that and stalling this because you don't fundamentally agree with something in it, you end up in a situation where you are preventing advancement of your own work by standing in opposition to something that you don't agree with. It creates a very, very difficult situation if a draft is out there where you have a problem with it, but you know that you want to advance something else. But to advance the other thing, you have to shut up and be silent because you know that it's not going to proceed in the context of the working group until the other one is finalized. That is problematic.
The problem, I think I'd like to make an observation here. SRv6 is not new, right? It's not something that's landing in the working group now and we're reviewing today. It's something that there has been consensus of this working group to adopt. And that's how this, the IETF process works. We work through consensus. So, and consensus consensus doesn't say absolute agreement from everybody. It says, rough consensus. And here we have rough consensus from what we can tell we had at the time, and it doesn't seem like the mood in the room is that there isn't consensus for SRv6. I understand that there's other solutions that are being proposed, but it seems like there's rough consensus and running code. So at this point, I think it's very difficult to argue that we shouldn't progress it. Now, to move on to the point of, is this blocking other work? I don't think it has to be. I think we're saying here that if you look at how SRMPLS and SRv6, actually, let's just talk about SRMPLS because it's less controversial. SRMPLS progressed outside of having a working group that adopted it and had running code way before that time. And it didn't stop that solution progressing, right? And at the time, the SRMPLS was in opposition to RSVP, and we had the same kind of discussion. So I don't necessarily see that this is any different in the pattern of there was consensus to continue working on something that's there. There is an alternative approach, and we can continue to iterate on them.
Jim Guichard from FutureWay. I just want to make a comment that the IETF works on certain principles and processes. And one of those processes is that a working group will work based on the charter. And if you look at the current Spring Charter, in the very first sentence, it says that this working group is there to work on SRMPLS and SRv6. That's the first point. The second point is the very next paragraph says that we should not be working on anything that is incompatible in the data plane with the existing solutions that we're working on. And clearly some of these other solutions are not compatible with SRv6. So can we just follow the process, and if other work wants to be done, use the right IETF process. Go get your own working group. Change the charter. Do whatever it is you need to do, but please don't bypass the process.
Darren from Cisco. One more comment on that process is that we've done that process for SR MPLS and SRv6. It's resulted in this. We have an architecture. We have a lot of maturity. If these other solutions, want to progress, at the very least, they need to define why they are better and why this working group should be interested in them, and that should happen in some sort of separate document. Right now, there's no justification for these other solutions that are kind of floating out there besides what the working group's currently chartered for. So I think the authors of those things need to seriously consider building that documentation to justify their work.
I think that's true of all proposals, right? It's not just true of alternative proposals. It should be true of amendments to existing proposals. And I think we should also remember that the documents that we've adopted as the working group are not individually owned anymore, right? They're owned by the working group. So things that go into working group documents should be by consensus of the working group, not by consensus of the authors of that work. Ron, sorry.
Okay, first, a clarifying question for the chairs. You said two things in bold print. We should continue on SRv6. I agree with that. And let's complete SRv6. But what you haven't mentioned is the degree to which other solutions are blocked. Will other solutions get floor time? Will they be able to ask for calls for adoption?
Floor time, I think, if you look at the agendas over the last N IETFs, I think the majority of our floor time is not occupied by working group drafts. And so absolutely, we have been giving individual drafts time in the working group. And I would see that if it's of relevance to spring, then, and especially if there's discussion of them on the mailing list, then that would be, it's fine to have floor time in this working group. I think
adoption calls?
I think that's the discussion that we'll have to have, right? I think in general, where we have, it isn't clear to me that we've got a good pattern that says, okay, this is the level of benefit that one has to have demonstrated to adopt something different. It's actually at the moment, we don't really have a huge amount of competing solutions that we're looking to adopt, right? And maybe where we did, like the NSH draft and the service programming draft, we've taken them on their own merits. We've had a technical discussion to say, okay, what does this work solve and what does this work solve, and we've adopted both. So I don't think adoption is blocked. I think, but I think we do have to have consensus of the group that it's something that's working on.
That adoption isn't blocked, consensus of the group, but that's IETF. Now, that's not a charter.
Run 2 seconds. You turned into a robot.
Okay.
Your voice broke up. Could you say it again, please?
Okay. That dropped quite a lot. So that's fair enough. Adoption calls are possible. Am I still a robot? I can see you smiling.
Unfortunately, it didn't get any better. Does anybody have some IM channel with Ron so that they could proxy, perhaps?
I can type in the chat.
Ron, if you type it to me, then maybe I can just relay it because we can't hear you at all.
Okay.
There's something ironic about being at the IETF and not having working internet connectivity.
Just remind me where you're typing it so that I can find it.
Oh, I'm texting it to you. Or can I put it in the chat room?
Stick it on text. I've got my phone with me, so. Okay, so Ron just wants to clarify that fair enough, adoption calls are not out of the question.
I think that's right.
Thanks.
And adoption calls there, I think then adoption will be gated as usual on consensus over the working group.
Oh, yeah.
Martin Vigoureux. Relaying Jabber. John, does adoption require a charter update? He didn't say adopting which document or... I was making a general comment about adoption. So if there's a charter update required, then that's something that needs to be discussed with the ADs and the ISG. Okay. So we have a fairly packed agenda. Today we're starting out with the SRv6 network programming draft.
Okay, so good morning, everyone. So my name is Pablo. I'm just going to do an update on draft IETF Spring SRv6 network programming. So a bit of summary on the draft status. So the first revision of this draft was published in March 2017. We have gone through 8 revisions as an individual draft, and we have gone through 6 revisions as a working group document. Throughout all of these revisions, the draft has been stable and there have been minor changes. But significantly, since the last IETF, we got a lot of comments from all the Spring community. I'm going to review them today. So the first review that we have since Montreal, so revision 2. In this revision, what we have done is we have done an integration with the segment routing header. We had already anticipated that we would need to do this editorial update. And basically, this consists in 2 parts. First, in all the section 4, all the pseudocodes for all the different behaviors have been rewritten following the same format as in the segment routing header. And then in the section 3, we have replaced many of the existing text in network programming by text from the segment routing header, which was already covering it, so that's already good. Then we have also removed 3 sections from the draft. The first is the end.s behavior. This was a behavior that was that is quite immature, and it was a research item, so it's not a part of this draft anymore. And then also we had 2 sections on segment routing our applications and non-segment routing our applications, in the sense of how we are going to bind a segment to an application. Now these 2 sections, so the segment routing hour and non-segment routing hour, are covered in the draft IETF Spring service programming. So just to avoid overlapping, we removed it from this draft. Then we went into revision 3. In revision 3, what we have done is we have moved the transit behaviors that relied on SRH insertion into a new separate draft. So this draft is an individual draft. So draft FISFIS Spring SRv6 Net PGM insertion. These transit behaviors with insertion are already deployed and are working, but there's an ongoing debate with 6man. So we just moved them into a separate individual draft. And we also moved as well the bind init with insertion into this document. Then in revision 4, we added also some editorial updates. So mainly we did some clarifications on the difference in between the SRv6 set function and the behavior. So the behavior is going to be the actual pseudocode that you are going to execute, and the seed function is the bit string that is actually bound to a particular behavior. Then following up from discussions that we had in Montreal, we have also updated the encapsulation when we are doing Ethernet. So when we have an Ethernet encapsulation, before we were using the as next header value the IPv6 no next header 59. So there was a discussion during Montreal whether this value should be used or not. We had a discussion at the mailer with 6man and Spring, and the outcome was that we should request a new value for Ethernet. So that's what we did. And also in the security section of network programming, on section 7, we had security considerations for intra-domain deployments with the security rules sec 1, sec 2, sec 3. By the time that we published the first revision of the draft, these were not covered, but then over time, this has been covered with more depth in the segment routing header, and we just have replaced the entire security section with intra-domain deployments in our reference for the segment routing header. The last update, that is the current version, is a version 5. We have done some more editorial updates to the text. We have fixed a typo on the USD flavor. So the USD flavor is allowed to decapsulate any IP payload, whether it is IPv4 or IPv6. And then on the Ethernet, we also did some clarifications, particularly regarding the preamble and the frame check sequence, just mentioning that these are going to be stripped before we are encapsulating them. Regarding this Ethernet, it's also important for the working group to know that we have requested the early allocation, and this is ongoing with the chairs and ADs. So a bit the feedback from the community that we got in Montreal and after. So we got a lot of discussion on the next header 59. As I have just explained, we actually took this aside. We changed the value for Ethernet, and that's it. With extension header insertion, we have decided to move this to a separate draft and just focus on standardizing network programming without it. The addressing space examples, this was a comment that was raised by Lorenzo and Jen during the last IETF. That was that in network programming, we had some examples that were using different sizes of prefixes, and it could be misleading. So what we have just done is remove these examples because they are not needed for the standard. And then we had the definition of effective next header in the draft. We have actually replaced that for upper layer header, as in the segment routing header. A bit the industry status for the draft and the running code. So we have 8 open source implementations. 3 of them are packet processing stack, so kind of Linux kernel, BBP. We have some open source applications. Then if we move into the hardware, we have 18 hardware implementations. These implementations are from 8 different vendors, and it's including Merck and Silicon. These implementations have participated in different interops events, so in SIGCOMM 2017, ENTC 2018, and 2019. And we are already working on the ENTC 2020, where we will have more vendors coming to the interop as well. And then finally, from a deployment perspective, we have, as per today, 7 deployments that are live, that are currently carrying traffic of millions of subscribers. This is SoftBank, China Telecom, Iliad, Line, China Unicom, Cernet2, and MTN Uganda. Most of these deployments, well, all of these deployments have happened in 2019, most of them in the second half. And there are also a few more deployments that have not been publicly disclosed, but overall we have more than 10. So given that the changes of this draft have been minor since March 2017, the authors of the document believe that this document is ready for working group last call. So that's it. Any question?
None?
Yes. In the terminology section, you mentioned that a single packet can carry 2 segment routing headers. Is that 1 per IP header or 2 modifying the same IP header?
So Ron, in RFC 8200, there is a text that says that regardless of the order of extension headers and regardless of their number of presences or the number of occurrences in a packet, we have to process them. So in SRv6 network programming, we are not suggesting to craft a packet with 2 segment routing headers. But if we receive a packet that has 2 segment routing headers, we must process it as per RFC 8200. So that is what.
Could you add some text that's in line with 8200, saying that a packet should not contain 2 routing headers, but you will process it if it does?
But the draft is not suggesting to craft a packet with 2 segment routing headers.
Well, actually, if you read the terminology section, it makes that suggestion.
Okay, we can discuss that on a mailer, but
okay.
1 sentence.
Greg Mursky, on that note, on a multiple SRH, what would be the order of processing multiple headers? So just their lexicographical, or basically the order how they inserted in a packet. I think that make it explicit. Basically, I understand that implicitly we all understand that it will be processed in this way, but explain it that if segments left 0 in first header, what happens then?
Just a quick comment on that, Greg. Darren from Cisco. 8200 does say to process them in the order received.
Okay.
I think that's already covered, but if you think there needs to be something else, you're certainly welcome to suggest it.
Okay, thank you.
Yes. One other thing you might want to add is whether you can always skip over the routing header when the segments left is equal to 0, or do you still need to look at the tags, flags, and TLVs?
Can you? So what network programming is defining is how you are going to process the segment routing header. The order in which you are processing all the different headers, it's defined in RFC 8200. It's not part of network programming.
Okay, so what you're saying then is, if segments left equals 0, you may ignore all the flags, tags, and TLVs.
If segment left is equal to 0, we do not process the segment routing header.
Okay, excellent, excellent.
Darren from Cisco. I think we're going to need text to describe that behavior, because I don't think that's necessarily the case. As to how that header gets processed. So we may need to add something there.
Zafar Ali. Ron, comment is more applicable to O&M. O&M draft does explain that it was discussed on the mailing list when a packet received is segment less equal to 0, and if O bit is set and if the TLV, we process them. So this was discussed on the mailing list, Ron.
Okay, then I think we have a bit of a conflict. I'm not sure who said that 8200 required to skip over the routing header when segments left equals 0, but we need to figure out what the rule actually is.
Let's discuss this in the context of O&M draft. This is described in O&M draft. We can have more discussion, but it's not something the network programming is. It doesn't affect network programming draft.
So we'll start the last call?
Yeah, I think so.
Okay. Thank you very much. Next is Kamran. Kamran. Okay. Sorry.
Hi, I'm Sonal Agarwal. I'm one of the new co-authors on this draft, and I'm working with Kamran. So just as a high-level overview, this draft was first presented in IETF 100, but just a quick overview, it has the SRV. So this draft was first presented in IETF 100, but there are 3 Yang models in this draft. A high-level overview is the base model, which defines the management and configuration of the SRV6 subsystem. So it defines things like locators, SIDs, all the counters, the path and the path list, among various other data structures. And basically, this model is augmented by other SRv6 technology models. And then we have the static model, which allows a user to program locators and SIDs in the forwarding plane. So these are the three models, the types, base, and static. And the types Yang model defines all the various end functionality types that we have. So that's just some history on when the draft was first posted. And we had another presentation in 101, and this is the third presentation. And from 101 to 106, we've had some revision changes, some major updates and cleanups, which I will talk about, and also some minor updates and cleanups. So some of the major ones are adding a lot of new end functionalities, which have all been added to the types Yang model, and adding similar changes to the static model, and also some data structure changes from feedback we received from various operators and co-authors, and then some minor cleanup changes of revisions and referencing other documents and some language changes. So some of the different end functionalities that we've added are OAM. In SR policy, we've added a couple. We've added several USD variants, and we've added EVPN end functionality. And all these have been added to types, and some have been added to static as well. One of the major data structure changes we've had are to convert enums to identities. And we've done that for SRv6 transit types, where we have a hierarchical representation of the parent and all the children identities. And we've done that for security type and for counter types as well. We've added a grouping, the SRv6 and CAP grouping, and then a hierarchical container type, the NCAP.
Sunil, I just have one comment on that. You didn't comment. AC Lindum, Cisco Systems. We did that in the base for a lot of things that we thought would need to be augmented, because unfortunately the Yang enum type is non-augmentable. So it really forces you to use identities, and this will help in the future to add more end functions with augmentations.
Okay. So this was just a new encapsulation hierarchical representation of hop limit and traffic class. And this is just a small example of what we have done for EVPN in the static model. Just an example of the Yang to program this in the forwarding plane. So the next steps for the drafts that we're looking at, we're asking for work group adoption, and this model will also be aligned with the SRv6 base model, and we would welcome working group feedback to take this forward with this working group. And that's it for the update.
Who has read the draft, the Yang model? Okay, and we believe it's a good start for a working group document. Anyone believe it's not a good start for a working group document? Okay, thank you.
So next, Cameron's going to talk about the SR policy Yang model.
Just to summarize, about 15% read and supported the draft, and nobody objected.
Okay. Hello, everyone. My name is Kamran. I'm going to present SR Policy Yang. List of co-author is listed here on the main slide. So this is basically first time we are presenting this draft. It's a Yang data model for SR traffic engineering policies to configure, instantiate, and manage those policies. This model is aligned with the SR policy main document in the Spring Working Group. And it generically applies to both MPLS and SRv6 data plane instantiation of the policies across these two data planes. So in terms of modules, we have defined two modules in this Yang. One defines the base SR policy types to define some of the common types and basic types that we want to use across our models as well as beyond our model. And the main module is called IETF SR policy module, which defines the model for the SR policy configuration and the management. In the policy types module, basically, we have defined, some of the key things that we have defined is basically different data plane types used across the policies, SID types, segment types aligns to SR policy main draft, about 11 type of segments that are defined there. And if that policy draft changes to use named segments or name-based segment types, we're going to align our model accordingly. But right now, the model is just aligned with what is the current revision of the draft, which is out there. And we also define different things for the binding SID and the protocol origin type. In terms of the state, various type of states that is listed in our SR policy architecture draft is also incorporated in our Yang model, which basically binding SID state, policy state, candidate path state, and any reasons for candidate path not being used or policy being down and whatnot. So if we really, take a 1,000-foot view of the hierarchy of this over model, really we have a segment routing traffic engineering as a top container. And within that, we have two sub trees. One is like attribute related tree, and other is really related to the policies. Attributes are really the common attributes that are used across policies. Examples are affinity maps, segment list, some binding SID related rules. And the policy has really, is a tree that to keep per policy configuration and management model. And within that policy, there are some policy-specific stuff, and then the candidate path subtree. And a candidate path could be an explicit type of candidate path or dynamic type of explicit path. So zooming in and double-clicking into these subtrees. So the attribute tree really has an affinity map, segment list, and segment list can define any type of segment from the base SR policy document. And then we have explicit binding SID rule that whether you wanted to allocate explicit binding SID from SRLB, you wanted to enforce it, you wanted to do fallback on dynamic and whatnot. So everything that is in SR policy document is part of this Yang model in the attribute section. If you go to the policy subtree of this module, then within policy we have policy key, which is color endpoint as per our architecture. You can also have a name-based policy tree if you want. There's an administrate priority of the policy and then the candidate path. Zooming into candidate path, candidate path keys is as per our SR policy architecture document, which is protocol origin, originator, discriminator, and the discriminator. And you can also have a preference and name for a candidate path. It's not mandatory, but if you choose to. And within a candidate path, you have an explicit candidate path type or dynamic candidate path type. Within an explicit candidate path type, it can specify one or more segment list, which is defined in the attribute section of the model. And then for the dynamic, I think this is the main change we made in the last revision of the draft. We did not have the dynamic attributes in our first version of the policy draft, Yang draft. So we added some dynamic attributes and constraint into our draft to cater for dynamic type of candidate path. And also along with that, we goes with the management of these things and operational state. Operational state is basically pertaining to the policy state as well as candidate path state, and the reason for something not being available or being down. I'll let you look at the draft later on. We also added some notification for some important event related to the SR policy management, which are really related to the status of the policy, the candidate path active status, as well as change of candidate path, one being selected over the other and whatnot, as well as if there's a collision about the explicit binding SID events, that's also captured in our model. We have few pending items which are really related to traffic steering and ODN templates. Having said that, there's also a companion document, which is BGP SRT Yang, which we also have submitted in IDR. That document already captures this traffic steering as well as ODN templates. So I think authors will be working with the authors of the other draft to see how we can align both of them together. The other draft augments our SR policy draft. And we might have some RPC action in future as well. So really, as a next step, this document has been around for multiple IETFs now. First time we have a chance to present this, mainly because of tight spring agenda. I think our document is in good shape. It is totally aligned with our SR policy main document in spring working group, and we are asking for a working group adoption of our SR policy Yang draft in this IETF. And also looking forward to any feedback and working group, input on our document to make it enhance it further. That's it. Any questions?
I'm Shraddha Hegde from Juniper. Go back to the tree, where
the main tree.
This one, the attributes one.
Yeah.
So there is this attribute section and affinity map. So is it like you're modeling this SR policy as a link? Is it why there is this affinity map here?
I think the affinity map is just for some of this dynamic constraint that we want to add to the policy. Having said that, we have received this input as well that some of this could be leveraged from existing T modeling, I guess. And we are looking forward to see that how we can align with already
constraints on that constraints for the dynamic policy. That's what it is it?
Yeah. Yes, about constraints. Yes.
Okay.
So who has read the draft? Not the same number, 15%. Who believes it's a good start for a working group document? Same number. And who believe it is not a good start for a working group document? Nobody. Okay. Thank you.
Thank you.
Next is Greg, I believe. And yes, yeah, two speakers.
Yeah. Okay, good morning. I'm Wu Changcheng from China Mobile, and here we give we have two drafts. One is for the unified the use case, and the other is for the solution. And we combine both presentation together in these slides. And for the unified seed, I think we just wanted to give some brief ideas here. So from the operator point of view, I think SRv6 give a very good solution, and we should appreciate it, SRv6 working group here. And but when we consider to deploy SRv6, we met some challenge. So here I just want to give some our understanding on that. The first point is that if we want to deploy a new SRv6 network, the first thing we should consider is that how we can open the TE traffic solution. In fact, for us, the best effort solution is enough. So SRv6 for us, the most important thing is how we can deploy the T, is not B. The underly solution is not overlay solution. So if we want to support better for the TE solution, we have to consider how many hops in the path we should give the constraint. And currently, based on our understanding, at least 10 level seats should be included in the SRH header, because we have to give the clear path in most cases for the high end requirement. So here I just give more than 8 segments in SRH should be supported. This is I collected a lot of different requirements from several operators, the similar requirement. And the other thing is that currently we have already deployed the IPv6 for several years. So if we need to replan the IPv6 address, that would be bad. And the other thing that we have a so big existing network, we hope based on existing hardware, we can support the basic SRv6 solution. So we want SRv6 is friendly for the hardware, is friendly for the existing network. So here, the problem we want to give is that the overhead of the SRv6. When we consider 10 seats in the SRH, that's a huge overhead. Only 60% payload can be carried by that. That is terrible. And compared to the SR-MPLS, even 10 seats, we still can get more than 90% over payload. So SRv6, if we want to support it in the bigger network, that is really hard. And while we raise the unified seed, we want to solve the problem, and we want to deploy that in our existing network. And based on the discussion this morning, I think we respect the current SRv6 work. I think that is great work. So the principle for us to develop the unified seed, the first one is we keep the compliant with the standard SRH. That's great idea. And the other thing is that we want to keep compliant with SRv6 programming or SRv6 operation. That's our principle. And here I give a picture, and which is the receiver side, how the original SRv6 handling. And the blue box is the original. And for currently, I think in IETF group, we have several alternative way to improve the SRv6 processing. I give a green box. So each of them needs some transforming. Some needs the shifting, the seed shifting. Some need the seeds stitching. And what we provide, we want to have a mapping table to solve the problem. Because, for the switching or routing chip, it's very hard to support complicated logic to process the SRH. But it's very easy to support some looking up table to support it, because it have resources there. So based on our understanding, even current chip can support it. We'll give some POC later. And the unified seed format is very simple. We will support something like MPLS Libre to support the seeds. And the The basic format of the label is that we will use reuse the existing seed assignment for SRMPRs. It makes it easy to upgrade from SRMPRs to SRv6. It also can be used for the existing networks that already has IPv6 address assigned, and it doesn't have enough new IPv6 address prefixes for SRv6 seed. It can use 20-bit seeds as a locator label mapping to IPv6 address, just like MPLS label. And here we have already two different POC. One is from Broadcom chip, and the other from Syntec chips. It's very easy for them to implement it. And Broadcom only takes 3 days, and based on current G2, implement their POC. And the solution can support all the current SRv6 functions, but the overhead is totally the same with current SRMPRs. It gives us very big confidence on that. So we will give more the POC maybe later. And the next step, we hope to get more comments, suggestions, and questions. And we also want to ask one question to our chair. If this work can be continued in 6-month group or the spring working group in future. So that's all. Thank you.
Hi, Ketan Talaulikar, Cisco Systems. A couple of comments. One is, I think the proposal is to put a lot of different mappings into the SRH, which was meant for SRv6 SID. What I'd like to remind is that we have in the Spring and MPLS working groups developed solutions for IPv6 using mappings or labels. So that's really something that the working group has already solved and addressed. That's number one. So we don't necessarily need to mix in this way. The other second part is that there is a draft for SRv6 and SRMPLS interworking. It's not in the working group, adopted draft as such, but I'd like to point to that draft and look for your inputs on that one.
Greg Mirsky, ZT. So if I understand, your first comment is that there is already a proposal to do a SRMPLS over IP. Yes. So yes, that's true. What we wanted to achieve here or preserve is that what we view as a important benefit of SRH that preserves the path information from the source to the destination. And SRMPLS in IP as SRMPLS does not do that. So that's what we think that the big differentiator of unified seed proposal to use SRH and thus preserve the path information of SRMPLS path, which is a benefit. Okay, so if we compare this proposal with the SRMPLS over IP, so yes, a lot of mechanics are similar between the two, but using SRH gives a benefit of path information being available to the egress.
So one is SRH is designed to carry SRv6 SID. I would think just using the header for carrying something different, is not really the same SRH. And the other thing is, there have been the interworking solutions, so we should look at it. We can discuss more offline, but these are the quick.
Yeah. Again, I kind of find it surprising that you're insisting that SRH can carry only specific size of SID. But yes, let's discuss
it. Yeah.
I'm sorry, just quickly, that was not my statement. The statement was SRH carries SRV6 SIDs. That was the statement. I did not talk about the size of.
Okay.
Kiriti Kompella. Couple of things. One is in the draft, you say that this is a way to upgrade from SRv6 to SRMPLS. It seems to me that you're more likely going to go in the opposite direction because there's more SRMPLS deployments than there are SRv6. So I think it's useful to talk about that particular option as well, or maybe even talk about that first. The second thing is you're saying unified SID, and you're talking about SRv6 SRH, and you're talking about SRMPLS. Are you planning in the future to talk about, having said a couple of times that the SRv6 is very heavy and kind of big SIDs, are you looking at SRM6 as another option within, because you only have 2 bits for your types, so you're kind of constrained on what types of, this unification, the space of unification is limited to 4 right now. So, but are you planning in the future to talk about maybe how this could interoperate with SRM6?
So I think the second question is about our flag. I think the flag here is to indicate what kind of seed we are using in the list. And we just give some proposal if we can use that. That is a reserve bit to represent that. But I don't think it's broken the SRv6 rules there.
Yeah. Greg Mersky, so as one of the co-authors of this proposal, I think it's a very good suggestion to emphasize that SRMPLS to SRv6 is a primary scenario. Because yes, we have more deployed network with SRMPLS, and as SRv6 or IPv6 networks come up, so to extend their programming of their network path using the same mechanics, it's operationally advantageous. In terms of what can be used using this 2-bit flag, as you notice, we think that for backward compatibility, we need to be compatible with the IPv6 SIDs. Okay, so 00 is given. Then we propose to use one of them to be to allow to use a SRMPLS case. 2 others are open for discussion. Yes, of course, there will be personal curative type. But yes, even we are suggesting that one of them will be IPv4, it's open for discussion. So again, we feel strongly about 2 cases, but 2 cases are open for discussion. So any ideas, suggestions, welcome.
Darren from Cisco. Just wanted to bring up a couple of points. We have RFC 8402, which is the SR architecture document. We have a SRMPLS SRv6 interworking draft. We've got a couple of compression mechanisms that work without any sort of mapping table. We have what I think was 18 implementations from 8 different vendors of SRv6. So I guess obviously those merchant silicon vendors are implementing SRv6 without a mapping table. I'm going to reiterate something that I said at the beginning, and I think that's applicable to this and the other work that's going on with SRM6 is that there's no description of what this work brings to the table for this working group or for the community in large over what's already defined in RFCs. Yeah. And I think that'll be a really good place for you to start is to find that so we can actually see what the benefits are here. Okay.
Yeah. Thank you. In fact, as you just mentioned, we have not given the detailed mapping functions, and currently in our POC, just looking for table, looking up a table. But I think it have a potential that we can develop some more smart way to optimize that.
Okay. And would you be building that that document that goes through the comparison and the details and justification for why this work is needed?
Yeah, I think today we just want to raise this topic,
okay.
and then we will give a further solution or some other detailed description on that in the maybe next meeting. Or we also welcome the question and the suggestion and even solution proposal for us. Thank you.
Okay.
Comrades, Cisco Systems. First, I found this statement that mapping solution is easier to implement in chip, even in existing ASIC chip. I found it interesting. But my main, and I'm not sure this is quite accurate because an additional mapping table you're talking about in hardware. But my main question is about the performance impact. So once you have a SID mapping table, right, this is an additional mapping table and additional lookup in the hardware, most likely. So you haven't touched upon that angle. So can you comment from performance impact, if any, for your solution?
Greg Merzgiti. I believe that if you compare this solution with the reference earlier, SRMPLS in IP, then there is no additional impact. So basically, it will be the same processing and the same number of mappings that you need to maintain.
Yes.
So again, compare it to SRMPLS and IP. Okay. And it works in wire speed. So again, no problem.
Robin from Huawei. Two comments. The first one, the previous slides, go to this one. Okay, I think this is regarding the compression of the SRv6 SRH header. So I think this 2 point is very important. I think the first one is the requirement. So I think here is the proposed the case. I know that the China Mobile is important the operators. So I think it's better that you can have some statistic information. That's the statistic information. You understand this the how much the size of this the packet and the distribution, and also this the according to the deployment, how many segments is necessary. I think this is maybe is more useful for us to understand this the requirement. So this is the first one. The second one, I think this is the cost of the new solution for this one. So I think that's better because now the proposed use case and also is better according to this the forwarding plane and also to identify some other requirements such as this the manager plane or the control plane. Yeah. So that's according to this we can understand this the advantage and also the possible cost. So that's we can have this comparison.
Thank you. I want to give you a brief feedback. So I want to give a example network in currently we are developing our SR MPRS network for our 5G backhaul. The example is Beijing. You know, Beijing is a big city. Currently, we plan to deploy 35,000 nodes to support the full city 5G backhaul. That's huge, right? So in this huge network, we have to manage each path between the base station and the core network of 5G. The number from is the 4G network. So for 5G, that's similar. So 35,000 nodes in one network. It's huge. The management, the control is challenged. So that's we have a very detailed calculation to calculate how many seats should be included in the height. And our number currently is 12. Now we are deploying the MPRS SR for this network. And we have deployed more than 5,000 nodes till now. And based on this network, we have to support more than 10 seats. or else it's very hard for us to operate that. So the seed number is related to the network scalability. For the big city, we have to have more than 10 level seeds. That's a challenge for the SRv6 now. So that means it's very hard for us to use the SRv6 in this network, in this application scenario, because this table. The 60% utilization of the bandwidth, it's terrible. So we have to improve the solution, or else we cannot get the large scalability deployment on that. Thank you. And the second one, yes, currently we just have a POC on the data plan. And maybe future we will have more detailed analysis on the control plan and management plan. Thank you.
Okay. David Melman from Marvell. I'm just curious if you compared it to the existing drafts about the microSID network programming draft, which also can support 16 or 32-bit SIDs. How would that work to meet your requirements for compatibility?
Greg Nerskizity, yes, thank you for bringing it. And that, in addition, and some other activity is for future work. So we'll do that. Again, we welcome comments, we welcome collaboration. So if somebody wants to work together, and in this aspect, comparing with the microSIDs or with other suggestions, enhance or do this, yeah, we welcome. But yes, we're planning to do more detailed comparison with the microSIDs.
Yeah, okay.
Charlie from Huawei. Also, we have another solution for like compressed SRv6 network programming as well. So it would be good to make some like comparison between these kind of solutions. Thank you.
Yeah, thank you. I think this figure lists several ones. I think we can have more detailed analysis on that. Thank you. Sorry.
We'll close the line after Ron.
Yes, I just did a quick back of the head computation. I think given the size of your Beijing metropolitan area network, if you tried the microSID solution, you would eat a /32 just for Beijing. So I don't think it would be a viable solution. The microSID wouldn't be viable in your Beijing metropolitan area network.
Okay, thank you.
So coming back to your question, it's part of the subject beyond SRv6. So we have multiple proposals on the table. We first need to really agree on what the goal is or are. We can't also add too many requirements compared to the original scope of Spring. I mean, we had requirements at the beginning. We can't multiply the number of requirements. We heard that there are some use cases with a lot of seeds, and for those use cases, we need to reduce the size of the header. But in addition to that, we need to really understand the real out goals. And then we have to discuss the benefits and cost of each solutions, not specific to yours, it's all the solutions. Because we should not assume that we are going to go to 4 solutions to 6 men. I mean, 4 solutions in addition to SRv6. So we really need to converge within Spring first. And well, it's up to everyone to discuss the cost and benefit analysis of each solution, and hopefully to converge on something. So far it's within Spring.
Okay, thank you.
Yeah. I just final question from is offers that what we asked for the chairs to clarify where this work can continue, and if it's to continue in Spring Group, would we need to resubmit the draft, the draft with points to the Spring Group? We just need your clarification offline on a list. Thank you.
We need to discuss it in spring. We can discuss any document with any file name. So far, it's up to you. It's really whether you want it to be identified with one working group or the other one, but we can discuss it in spring, whatever the file name. Next, I believe, is Reggie.
Okay, my name is Reggie Thomas. I'm from Juniper Networks. Since Ron couldn't come in person, so I would be presenting the slide deck for him.
Maybe, yeah. Close to the mic.
Okay, so Reggie Thomas from Juniper Networks. Since Ron couldn't actually be in person over here, so I would be presenting this slide deck for him. So we'll start with the changes since the last IETF. There's a typo, it's 105. So the title has been changed. Now it's called SRM6, as you could actually see from the title. Earlier it was SRV6 Plus.
Just one quick comment is you guys haven't changed the name of the document, and that's still causing some confusion in the field, right? So we need to change that name and in presentations as well.
Yeah,
So
I
let's
guess
make sure
the
that
others would
happens.
take note of that. Yeah.
Thank you.
And then we have a binding set which got added onto the overview draft. And yeah, there's a new co-author, Lua Jalil from Verizon. And these are the individual drafts which are currently on SRM6. Couple of them are like a work in progress where like a development is actually happening. However, there are like some of these drafts which we believe are like quite mature, specifically because there have been implementations both on software and as well as like on ASICs, and there has been interoperable implementations. So I would just like go through those which we believe are mature. The first one is the SRV6 Plus, which actually gives an overview. And then we have a routing header definition that we believe is pretty mature because, as I said, like there has been implementation both on software and ASIC, and there has been interoperable implementation. The other one, VPN desktop, it's a very straightforward draft, and we believe there's an implementation, and believe that one is also mature. So otherwise, from the last IETF, we have a new draft, which is CRH helper opt. So the others are over here itself. So if anybody has like gone through the draft and if they have any suggestions or comments, they can actually directly reach out to them. So in essence, it actually defines a new IPv6 destination option that actually carries the mapping from the CRH SID to the IPv6 address. They do it efficiently. So I didn't go into the details because the draft is like a pretty much clear on that. So any doubts you can actually ask. So with respect to the development and deployment, we have a POCOD, which is like a Linux based, and we have an ASIC based implementation also, which is on MX. And there's a DPDK implementation from Liquid Telecom. Regarding the deployment, Andrew would be talking after me, so I didn't get onto that. And with MX-based POC, there are like other deployments which probably would be like coming on the coming quarter. And with respect to the drafts which needs to be written right there, there's an OSPF extension similar to ISIS which needs to be written, and there is a Yang model which needs to be defined. And from the presentation, the ask is actually for the community to actually review the mature drafts, because those has been implemented, and you have like a implementation on both ASIC as well as like on software. Probably we could actually get comments at this time. So yeah, I would have like Andrew come on stage here. Yeah, questions?
Okay. Yeah, Darren from Cisco. So like I said on the last draft and at the beginning, we don't see any justification for this SRM6 work beyond what the working groups already chartered deploy or chartered to produce and is producing, and multiple vendors and operators are currently deploying. So there's no comparison document, there's no justification for why this work is of value to the community. And I think without that, I don't know how this community can figure out if there's, why they'd spend time on this or why they'd work on this.
From whatever I understand, there are customers who are actually interested in SRM6, and that's the reason why this is actually getting progressed. So probably if the others want to add more, they can add.
Darren, I'd like to add a couple of things to that. Firstly, I go back to Montreal, where we were asked by the operators to put down the justifications of something needed in addition to SRV6. This was done. There were multiple emails that I can point you to on the list from ourselves, I believe from NTT, from others, about the justification needed for something additional. Secondly, I point out, that I myself, as an operator operating a large network, was asked a question about SID depth and deployment and whether or not the current technologies could be utilized. And I laid out the scenario and I put it back, and I was told there'd be a response. That exchange was between you and me. So to stand here and say that there is no justification, considering the work that has gone on the list where it was asked for, it was replied to, is...
So the question is, where's the detailed description of how this work, how the solution this is trying to solve is not already solved by what exists? There's methods of reducing the size of a header. There's SRv6 is already has an architecture doc and has the control plane defined. It's deployed. So it's back on the authors of this work to describe why the current work of this working group is not applicable. You've got massive changes to what this working group has been working on, and you're suggesting to do something very different. The onus is on the authors of this draft.
Okay, so first thing, I think that it needs to be made very clear that the authors of SRM6 have stated multiple times on the list that we do not want to impede the work of what is currently going on. We believe that there needs to be a choice and let the market decide, and we believe that both should progress. I also point out that if we look and when we talk about finalizing one before the other, there is one architecture document before this working group at the moment. It is SRM6. SRH is sitting in 6-man. It is not in this working group. Network programming and CRH and SRM6 perform very, very different functions. Very different functions. If you get to the microSID draft, I point out that the CRH draft actually predates that. And so the same onus that we have to produce the justification for what forms in CRH sits on the authors of the microSID draft and is equally absent. However, considering that the authors of the microSID draft wrote the microSID draft, they themselves have acknowledged, considering they are the same authors on the original SRv6 draft, that something has to be done, that there is a problem. The document itself stands as an acknowledgement to the problem of the overhead. And so the same onus applies there. So I'm a little confused here as to what the stance is. And if you can explain it to me better, considering everything that I've just said.
So,
sorry, Martin jumping in the queue. Just a small precision. SRH is not in 6-man anymore. It's in the RFC editor queue.
Okay, that works in exactly the same way. I'm just trying to understand when we talk about we have to finalize SRv6, what are we talking about here? What
there
are
was
we
a,
trying to finalize? The
there was
network
discussion
programming, the
from-
microsid, what?
There's discussion from, I think, Rob, who said at some point we'll need to define a set of requirements around and what's needed as far as a reduced overhead and what's needed and why it's needed. I don't remember the exact words of that email.
But Darren, here's my
But
confusion.
that exists. So you have a solution that has a RFC 8402, which is the SR architecture document. You have a lot of work that's been done in the working group. You have a lot of work that's been done in the industry. You have a lot of deployments. It's going the way it's going. What I'm simply stating is that there is a lot of background work to build that documentation set and this working group. And I don't see the same level of background for this work.
And I would say to you,
and I think you
Darren,
need to put the work into doing that.
And I would say to you that there is a lot of work that has gone ahead. I will point out that when the questions have come from the working group, we have attempted to address every question that has come up. There were requests in Montreal put for justifications to the list by the chairs. The request went out. It was answered in some detail, and I'm quite happy to point out those emails. My point here is that I really do believe that there is a lot of work that has gone on into making this what it is today. And the authors have said very clearly that if this working group feels that there are technical problems with it, technical changes, bring them to us. And where they have been brought to us, we have attempted to engage, to address. But at this point, I'm not quite sure what it is that you want from us. And I'm quite happy to have an offline email exchange to understand that better. But right now from the...
Can I? So this Ketan Talaulkar Cisco. So this proposal is mapping, SRM6 mapping, right? We have a 2-decade plus old technology for mapping, which is called MPLS. I would like to point out that when we are talking about IPv6, we have already in the working group defined SR-MPLS for IPv6. We have also defined it's in the RFCQ how to do SR-MPLS over IP-only network. That is SR-MPLS over IP. All of these are there. Right when this proposal was brought out, there was a discussion in the mailing list, and the authors were asked to differentiate against this and what is it that cannot be solved or addressed with this technology that warrants this new proposal, right? I think it's a bit of odd that this gets compared to SRv6, but you are silent and ignoring the functional benefits of why this cannot be achieved with what we have done previously with SR-MPLS. So that would be the question. I think we need some text or some information from the authors to cover that aspect. It's not just, this is not SRv6.
I think that as I've stated on the mailing list, right, there is a demand out there in the market to move away from MPLS labels at the top of the packet. And we've seen it. I was told very bluntly by a particular vendor that there would be no more further control plane development done in V6 as regards MPLS, right? Now, our take on this is that in the current SRv6 as it stands, and I have, as I've said, no wish, none of the authors wish to block the deployment of SRv6 or the development of it. We simply argue that there is a need for the ability for a far deeper SID stack, and there are requirements for it. If you look at the previous presentation, they were talking about a 10 SID depth. That is a requirement. I myself have a need for 10 SID depth. If you look at the overhead imposed by SRv6, in the absence of the micro SID draft.
So just if I could kind of paraphrase you, sorry, what you're saying is that with SR-MPLS, this solution for IPv6 only network is solved or addressed by whatever work has come out of Spring Working Group and MPLS, right? But what you are looking for, so that's the case, right? Did I understand that correctly? So with SR-MPLS, the deployments or the problems that you want to do with IPv6 networks have been addressed.
I would say that in part. I would need to answer that more fully, and I'm prepared to address that question on the mailing list.
Just to say, that was what I was asking about. So this is addressed or solved with SR-MPLS, right? For IPv6 networks, with IPv6 control planes, with whatever work we have done. I find it a bit odd because we are introducing a mapping technology, and mapping is very similar to MPLS, and we have done all of that work. So
did you guys not introduce SRMS to map?
Yes.
Mapping technologies. Mapping technologies are part of the internet. There were many of them.
Yes. So that's,
and there were alternatives in protocols. Operators, right? Many operators want a choice. They want to be able to say, got this option, right? And
sure.
And what I am saying, and again, I repeat, right? There is no desire to block the continued development in SRv6. We merely believe that there is an alternative. There was a stated requirement for what the alternative offers on the list as requested after Montreal. And as such, we believe that both should be able to proceed.
So
can we cut this question now? I think that we're looping. So Ron had a remote comment, and then we'll cut the line as well, please.
And please don't repeat the same point again and again. You can refer to an existing point, but let's not loop on the same thing.
Can you hear me? Okay. In response to Darren's questions, what are the differences between SRM6 and SRv6? At the end of what's the motivation for SRM6? At the end of the SRM6 document, there is a section that calls out the major differences. CRH size, decoupling of network programming with traffic engineering. There were a few others. We can beef up that section a little bit in the next revision and call them out as the real motivation for SRM6. One of the major motivations that you'll see in this next version is that SRM6 does many things: traffic engineering, fast reroute, VPNs, per segment service instructions, and it decouples them so that if a network operator wants to use one, the other, or some combination of them, that's fine. Also, it does a good job at all of them. It can do traffic engineering without requiring the network operator to number his network in any particular way. It can do traffic engineering using adjacency SIDs as deep as it needs to go. So in any event, your comment is well taken. You'll see an update in the next revision. That section that calls out differences will become more a motivation. Why do we need this in addition to why do we need this in addition to what we're calling SRv6?
Okay, Ron, this is Darren again, really quickly, since you mentioned me. The content in Section 9 is all resolved with SRv6 in its current form, and the now I think couple of XRv6.
I disagree strongly.
Supported and with reducing the
far from being adopted and far from being deployable, and also there's a good argument for decoupling network programming.
None of those arguments are made in the document. That's why you need to do the work of building that separate document that defines these, so that can actually be discussed.
Okay, well, I think it's a matter of beefing up that section, turning it from these are the differences to these are why we need these differences. You know, I think that's what you're asking for, no?
So I think Ron and Andrew, the work here started SRv6 6 years ago. There's an architecture document, data plane is an ISG. Okay, there is a document.
This is the same point, please.
Now,
Zafar, can
you
make
are defining a
original?
new control plane, new data plane, and deviating from architecture. This is why you need to work on this, because there's a whole list of documents that Andrew just showed on the list. It's all control plane document, entirely new control plane, entirely new data plane, and entirely different architecture. This is why you need to justify why the 6 years of work.
Zafar, this point's been made. Thank you
cannot be
very much.
reused.
Thank you very much. Jim and the back line, please.
Yeah, Jim from Futurewell. I was actually going to reiterate that point, that my concern here is that we're being asked to develop two completely incompatible solutions in a working group that's not supported by the current charter. And if you look at just the second paragraph of the charter, it specifically says that we should avoid working on incompatible data plane solutions for existing deployments, or words to that effect. And what we're being asked to do here is work on another data plane that is completely incompatible with SRv6, and that's the danger.
Well, hang on a second. When we say another data plane, I understand that there are two data planes at play here, MPLS and IPv6. I don't think anybody's defining a new data plane.
Yes, but
I'd
the
also,
charter,
can I just add to this,
Ron,
right? When we
Ron,
start talking about data plane, okay, I need to make a point here. If we talk about data plane compatibility, I published on the list a test that we did with the compressed routing header, where I routed and steered compressed routing header over my network out across the general internet, across 2 continents, into another network, and took up the steering on the other side. That was over a V6 data plane. The traffic steered on my network, it steered on the remote network across multiple ASNs with no knowledge of the intermediary networks. So the argument that this is a completely incompatible data plane, if this was a completely incompatible data plane, my packet would not have moved from Africa all the way through Europe to the Netherlands, all the way through another network with full steering.
No, but to be fair, Andrew, that could be, you could achieve that with SRv6 as well, quite easily.
Well, actually, I'd like
Ron, let me just finish. And there are solution documents out there that suggest how you can compress the SRH and so forth, and that's a discussion we need to have. All I'm saying is that the process in IETF is that when we build working groups, we have charters. They're there for a reason. And if we're just going to ignore what the charter says without going through the process, then what we have is anarchy. And that's my concern. I do not want to be working on 2 completely incompatible solutions. That's it. And if we do, we need working group consensus to do such a thing.
Well, clearly we need working group consensus. However, I'd like to point out what the 2 data planes are. They're MPLS and IPv6. And in order to really be compliant with that charter, we need to comply both with the spirit and the letter of RFC 8200, the IPv6 standard. Whenever we stretch that, then we risk stepping out of charter. So, I think we do need to stay in charter. That means do an IPv6 data plane. But I think it's a bit unfair to say SRv6 is what we say it is today, even though we're not quite finished yet. Let's let it evolve. And also let's be very meticulous in our compliance with 8200.
Okay, John.
John Scudder. So I thought we were done with process attacks in this group, at least 5 years ago, and it's personally disappointing to me to see it still going on. Actually, that's almost the only thing I want to say. I'll just say one further thing, which is that what I see now is what I saw a bunch of years ago, which is that there are some people who are trying to solve what they say is a demonstrated problem that they see from the marketplace. They're feeling customer pull, and they have a solution they're working on. They would like to work on it in the light of day. Toward that end, they've put a lot of work into publishing a set of documents and soliciting input on them. The work is, I presume, and I should say that although my badge is Juniper Networks, I do not work on this project. But, work isn't going to go away because the IETF says, la, 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 I can't hear you. That's it.
Robin from Huawei. I have two comments. The first one is the requirements. So the first, I think we must distinguish the two types of the requirement. The first requirement is to reduce the size of the SRv6 seed. Another requirement is a totally new the IPv6 based the SR solution. So from my point of view, we cannot mix the two requirements together. I think it's not a reasonable way to say that we want to reduce the size, but this is our requirement. But based on this requirement, I make a totally new IPv6 based solution, SR solution. I think this is not a reasonable way. So you can say that there are already the three possible solutions. It can be compatible with the SRH. It can also reduce the size of the SRv6 seed. So I think this is the first point. The second point, I think this is a process issue. I think this is also mentioned that in the AD's mail, that is refocus on this, the SRH as standardization. This is the first point. Okay. The second one, I think if you said this, we have the requirement. I said that you also comply with the process. You had this is proposed as a problem statement and the requirement. So this one, that is the charter. So after that, you get the rough consensus. If you think that the people support this is the totally new requirement, okay, so that's maybe you can go on. Or else, I think we need not to repeat this work. Okay.
So Pablo from Cisco. This draft is not describing segment routing as defined in RFC 8402. You are describing a method for doing source routing by means of stitching IP tunnels. This is not RFC 8402. So my questions to the authors is, why do you call it segment routing?
I'm actually trying to process in my head what you mean by that. Considering if I look, right, let's compare for a second. In SRv6, you are using IPv6 addresses as SIDs, and then you are using those to effectively rewrite a DA.
I am not discussing about SRv6. I'm trying to discuss about your proposal. And if I read the introduction of draft Bonica SRv6 Plus, you are defining something that is called segment node ingress and segment node egress. Then you are saying that the segment must have a state both on the ingress and the egress. And to me, that looks more like a tunnel than rather than RFC 8402.
I think in reality, if we rename this something that doesn't say segment routing, it doesn't change the problem space that we have. The problem space is there are multiple solutions for a smaller header size. If it's segment routing or not, potentially your problem gets even worse because this moves to RTWG and things just happen outside of any kind of coordinated view. So I appreciate the point, but I kind of feel like it's not necessarily moving the debate forward.
Okay, I'm from Tsinghua University and running CERNET, China Education Research Network, and I believe we have the largest IPv6 only network. And actually, we did SRv6 test with Huawei, and it's interesting. However, we also noticed that shorter seed has opposite advantages. For example, handle smaller MTU, and actually, because in some cases we run control plane directly control the seed. Actually, in that case, we do not really need 128. So actually, we support both proposals, and SRv6 because it's quite mature, so it's good, and we are using. And we should open our eyes to see the new possibilities, which is this RFC, and probably we can try to get it compatible in the future for the features. However, one thing I like to emphasize, if we want to do compressed seed in the current version, then actually that's changed the definition of the segment list, which is 128. We should avoid that. Thank you.
Cameron.
Okay. Cameron with Cisco Systems. In your earlier slide, you shown one CRH and 3 option TLVs and also proof of concept with ASIC-based implementation. My question is, and I'm interested to know that how many on ASIC-based implementation, how many of those options at the line rate you can process, including CRH and 3 other options that you have listed?
You are talking about the network programming part?
I'm talking about your earlier proof of concept on ASIC-based implementation and your list of options. There are 3 options, the latest being CRH helper option, and you have 3 option TLVs and 1 CRH header.
Yeah,
so all these options, TLVs/CRH, how many you can process on ASIC-based implementation on line rate?
Okay, so I talk about the POC, which was done. So that's the traffic engineering part. And we have a VPN label part, which is the N.DT4 and all, that can be actually processed on a line rate.
We can talk further offline. Thanks.
And the line was actually cut behind Cameron, so just to hold on to, let's stick to the way that it works for fairness, please.
Can I still?
Okay. Please make the comment on the mailing list. Okay. So we're going to move on to the next.
Johnny from Huawei, I just want to mention that
that's
the
not how
cost. Think about
works.
the cost. TLV costs some like overhead as well. So it's not about reducing the seats only. So think about the cost overhead of the destination also had.
And then finally, Chairs, from our side, we do feel like we would like to ask for a consideration of adoption of the SRM6 overview draft.
So we are back to the same slide that we discussed at the beginning. It's beyond SRv6. We heard the requirement to propose a new solution with a shorter header. We need to make sure we really understand the problem that we need to solve, because we are hearing different things from different persons, including from different authors of the document. And then we'll work on a solution. We should not assume we're going to push 4 additional drafts or 4 additional solutions for 6 months. So to make it short, if the goal is to make a shorter header, we need to ask to all the proposals, if you just need a shorter header, any solution could work, or do you really want your solution only, or then why? So we need to understand the why first, so that when we come back to the real reason, it should be easier to prune a solution, or to accept that we cannot move forward.
And just to make a follow-up point is, if we do a call for adoption, we're only going to get the same comments that we've had in the room and the additional ones on that basis. So I think we should really, the focus before we kick off for an adoption for anything should be to start to address some of the concerns raised in the working group.
And finally, to your question, USEED is not part of SRv6 that we need to finish before.
Good morning, everyone. I'm Cheng Li from Huawei. My topic today is about SRv6 per segment. So, in the history, we have proposed the draft about SRM pairs per segment, and it has been adopted by the Spring Working Group, as you see that. The reason is, in SRM pairs, we cannot identify the package came from which ports, because there are no label or only few label left when the packet reach the egress node. So we need SRMPRS part segment, right? So to support use case like PM performance measurements and something like this, we need a path identification. And in SRv6, we think the segment list is not the appropriate ID or to identify the path, because it is flexible length like fields, and even in the reduced mode, the information of the seed list cannot identify the path. So we need an ID to identify the SRv6 path. So we propose SRv6 path segment, which is a fixed length identification, which is a 128-bit ID. And so the main update of this document is we add some tests to clarify the requirements of SRv6 path segment, and we move the encapsulation related test to another document in a 6-man working group, and we update the references, and we make some editorial modification. So any question and comments are very welcome, right? So this is the SRv6 path segment encapsulation in SRv6, and I won't go into the details of this solution because we're talking about the architecture document. So if you are interested in this document, welcome to discuss with me. So we mainly propose two formats of SRv6 segment. The first one is a global ID format, which is it can be a 128-bit global ID, and the second one, it follows the format of SRv6 segment, which has the locator and function ID, something like this. So this is the format, the processing of the SRv6 path segment. I won't go into the details. What I want to mention is the SRv6 path segment can be distributed by BGP or PCEP, and we have two documents have been adopted by IDR working group and PCE working group. So it can be very easy to support SRv6 by some minor changes, right? So the next step is we request to working group review, and if possible, we request to working group adoption of this architecture document called draft lead spring SRv6 path segment, and because the text is mature right now and requirement is clear. And welcome to discuss with the format of and encoding or encapsulation of SRv6 path segment and with me. And any question? Okay.
The question? Very short.
Yeah, just one comment. I think this solution is really important for the network operation, especially for the large network. Thank you.
Thank you.
Thank you.
So that's it.
So we are very late on the agenda. We just have one slot remaining, and we propose to give the slot to Rio to give a feedback on a working group document, and also is from Tokyo, so he's not likely to come back to another meeting. So Rio, thank you. And we're sorry to the two other slots. So Rio, you have your 5 minutes, but it's 5 minutes, so maybe 13 slides will be too much.
Hello, I am Ryo Nakamura from the University of Tokyo, and I'm also a team member of Interop Tokyo's ShowNet. So this draft would like to share the lessons learned from the large-scale SRv6 service training deployment at Interop Tokyo. So the only Interop Tokyo still continues the ShowNet, which is one of the largest demonstration network at the Interop Tokyo Interop exhibitions. So we conducted many demonstrations at the Interop Tokyo as a ShowNet, and we used the SRv6 service training based on the SR service programming draft in this year, and we provided the network connectivity to all the exhibitor booths and the visitors at the Interop Tokyo using the SRv6 service training. So this is the overview but I will skip this slide because not so interesting. And so this list indicates the SRv6 aware devices contributed to the shownet for this experiment from Cisco, Huawei, Furukawa Electric, and NTT Communications, FDIO, Trend Bike, and so on. So please see the draft about the detail of the product. And they are the services deployed at the SRv6 sub-chaining as the SRv6 unaware services. That means that they are deployed under the AM proxy or tagging proxy. The tagging proxy is proposed at the shownet, and the draft is also published. And so let me introduce or share the lessons learned from this experiment. So the first, so we were worried about that such a middle boxes could pass the IPv6 packet with SRH under the and AM proxies, but there was no worry. And all devices contributed to the shownet this year transparently delivered all the IPv6 packet with SRH under the end AM proxies implementations from some vendors, 3 vendors. And so next, so we would like to, we tried to deploy the captive portal under the AA proxy for Wi-Fi users, but it couldn't be done because, as mentioned in the draft SR service programming, the services, they originate the packet from the service itself, cannot be deployed under the NDM proxy because the demasquerading requires the SRA, demasqueraded SRH with the packet, but such packets from the services don't have the masqueraded SRH. So we need the variant 2 of the masquerading proxy in the draft. So next is the service liveness detection and the conditional advertisement of service segment. That means so to achieve the redundancy of the services under the SRv6 based service chaining, we need to detect the down of the services. But there are no functionalities to detect that because the current implementations focused on the data plane functionalities. There is no such a control plane mechanism. So such a mechanism to detect the liveness of the services from the proxies are required to practical deployment. For example, integrating the BFD, bidirectional forwarding detection, into the advertising the service segments. And next is the hop limit decrement on the SRv6 proxies. We noticed that there are variants of the decrement behavior of hop limits on the SRv6 proxy. An implementation decrement the hop limit on the masquerading part, and then decrement the hop limit on the demasquerading part. But another implementation doesn't decrement the hop limit on the masquerading part. So, but the former is the correct behavior as mentioned in the on the mailing list from Francois. So next, the control plane capabilities. We really need the control plane capabilities. At that moment, the devices do not have the control plane implementations because they were focusing on the data plane. So we configured all the SRv6 components by ourselves, by our hands. It was possible, but it was actually very, very hard. So we strongly hope the functionalities in the control plane draft would be implemented in the product. And this is the last final slide. So match condition for applying SRv6 functions. So basically, current implementations apply SRv6 functions as a result of longest prefix match as on the routing tables. So, but in the service chaining, transit behaviors need to be associated with the default route because the packets from users would have arbitrary destinations. So we need 0.0.00 or 0:0/0/0. But so, and we need to apply the different SR approaches for different users. So we used VRF for service chains. But so using the VRF is a very practical candidate. But we suggest there is another candidate, for example, using BGP prospect So if the BGP flow spec could apply the SRv6 function as an action of BGP flow spec, we can use only one routing table to apply the different SR policies for different users by just advertising the BGP flow spec routes from route reflectors. So this is just a suggestion. So this is all of the slides, and thank you. And we hope the lessons learned from the Interrupt Tokyo will help this community. Thanks. 5 minutes.
Thank you for the feedback. In general, you're very welcome to contribute to the mailing list, and especially if you find the interrupt issue, you should assume that the specification is not clear enough. So you're welcome to send comments and say that that's not clear, we found issues. So please contribute.
Yeah.
Thank you.
Thanks.
So we are finished for today. We have another meeting in Thursday, I believe, which is full also. So please discuss on the mailing list in the meantime. Thank you.